Spanning tree protocol. This powerful layer 2 protocol, whilst it has a bad reputation, and rightly so, prevents loops within a switched network by blocking certain links. And in this video we will go through how easy and quick it is to configure spanning tree protocol on Juniper switches. Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video what I'm going to be going through is how to configure STP or spanning tree protocol on Juniper EX switches. And I kid you not, it is so easy to do. It's very quick. It's not really much of a hassle when it comes to configuring this protocol. So I'm going to go through how to configure it, and then what I find are the useful show commands. Now, I'm not going to do any theory in this video. This is assuming you know what STP is. It's assuming you know what the limitations are on the different port rows and the port states, and what a root bridge is, and how they exchange BPDUs, and what is a BPDU, and those really important timers. Now, if everything I just said is way over your head, you don't know it, please check out this link. It's a video I've done that explains all of that STP theory for you. Other than that, let's just go straight into the lab, straight into configuring a spanning tree protocol network, and then we'll go through those show commands and see what links are actually blocking, what are root, and what are designated. And I will also have a host which is going to create a topology change, and we're going to see those BPDUs going back and forth. So it's going to be very exciting. And here we go everybody. Here's the lab that I'm going to be using to configure spanning tree protocol, or STP. I'm just going to call it STP moving forward. And as you can see, there's 4 switches: switch 1, switch 2, switch 3, and switch 4. And of course they've got this nice great big loop going on, haven't they? Because they're all, I wouldn't say connected to each other, but you can see switch 1 is connected to switch 2, 2 to 4, 3 to 4, and 4 back to 1 again. So that is just a good example of a loop. Without STP, that would be obviously forming a loop. And what you can also see is, and this is the goal, is the ports that will be configured either in a designated port or a root port, and the port state, i.e. is it forwarding or is it actually blocking. Now again, I'm not going to go through the theory, but just very quickly, a root port points towards the root bridge. It is the best or lowest cost for that switch to get back to that root bridge. A designated port is a port that points away from the root bridge. It is designated for that particular part of the LAN segment for that collision domain. And then we've got this block port, and really, as the name implies, that is blocking any traffic from being received. It will still receive BPDUs, it will still listen to those BPDUs, because it wants to know in switch 2's case that switch 3 is still there, but it's not going to process those BPDUs, it's not going to do any MAC learning, etc. But again, if you want to know the theory, please just check out that link, it's all explained there. But a question for yourselves: what switch is going to be that root bridge? Hopefully you know the theory and you can see and just immediately identify that it is going to be switch 4. There's a few different ways you can actually determine that. One is by the priority. With STP, lower the priority even if it's on port priority or port ID. Lower the value, the better and more preferred that actually is. So this with a priority of 0 means that switch 4 will be the root bridge for this layer 2 Ethernet network, because if we look at switch 3, it's got a priority of 4096. Switch 2, it's got a value of 8K, and back to switch 1, this has got a value of 4K. So by far the priority of switch 4 is preferred. The other way you could actually determine, if you didn't see all this information, so this was crossed out and this was crossed out, you just basically couldn't see this, how would you know that switch 4 was the root bridge? The way you could identify that is that with the root bridge, all of the ports are designated. So you can see we've got designated port for this interface, and we've got a designated port for this interface here. You're not going to have a root port on a root bridge because the root port points back towards the root bridge, so you can't then have a root port on the root bridge pointing back to itself. That doesn't make sense. So those are two ways that you could easily identify. The reason why I'm saying all this is because all the configuration that we're going to be doing is on switch 4. Now switch 1, switch 2 and switch 3 have already been configured for STP. I'm only going to show it once because I kid you not, this is so straightforward. So here we go. This is how you configure STP. And here's my secure CRT on switch 4. And I'm just going to go into command line interface. Let's go to the configure mode. And let's do edit protocols RSTP. Now RSTP, or rapid spanning tree protocol, is more preferred to STP. You're not going to find STP under the protocols. So if I just go back up one and do edit question mark, you can see all of the protocols on the left hand side here, but note there's no STP. There's SAP, SFlow and source packet routing, but there is no STP. There is RSTP, not RSVP, RSTP. So the reason why you do not see STP there is because RSTP is more preferred, it's quicker, and also because when you come into the protocols RSTP on Junos, you could do, I want to set force version. If I hit question mark, now you can see STP here. So what we're telling Junos is I don't want to use RSTP, I actually want to use STP. So that's how, just initially, you get STP, I wouldn't say configured, but the protocol of choice on Junos EX and QFX switches. But of course we need more configuration than this, of course. So one of the other configurations we need to do is actually define the interfaces to participate in spanning tree protocol. So we've got the GigE 001 port, which is going up to switch 1, and then we've got the GigE 003 port, which is going over to switch 3. So those are, again, two very quick, easy commands that we can do. So if I just do set, hit question mark, you could see all the variables that you could do for both STP and RSTP. So we could give a bridge priority, we can disable STP, we're not going to do that. We could configure the hello time, so the time that the hello packets, hello BPDUs get sent out by default every 2 seconds. The forward delay timer by default 15 seconds. The max age timer by default, that's 20 seconds. So what we want to do though is we actually want to define the interface. So let's do set interface GigE 001. If I hit question mark, these are all the sub commands that you could do within the interface. So I can define the cost. Now this is important, and I'm going to explain more in my next video where I configure and explain through RSTP. But with STP and RSTP, there's this concept of short and long costs. Short costs being 16 bits, long costs being 32 bits. And by default, what you're going to see in the STP and RSTP world on Junos is long cost. It's actually more preferred, and it's just there by default on all newer switches. On older switches, you'll see the short cost. But I want to configure the short cost here because I kid you not, the long cost where it's 32 bits, the values can be quite, guess what, long. But we can actually see the cost here of 4 and the cost here of 4 on those ports. So I'm going to do a cost of 4 on the GigE 001, and if I hit back up to GigE 003, cost of 4 once again. Now if I just hit back up and hit question mark again, you can also see all the additional commands that you can configure in the STP world. So we've just done cost, so we're not going to do that, and I'm not going to worry about these 3 commands up here. What we can also do is define these to be edge ports. This is important because what you can do is you can configure the switch to block those BBTUs, those bridge protocol data units, on edge ports. So say for example we had an interface that was connected to a terminal, so not a switch, and there was a user there using that terminal, that PC. What you don't want to happen is for BPDUs to come into the switch and then switch 4 sees, hang on, I've now got this device, presumably this networking device, connected to me, and what's going to happen then is that they're then going to do that STP process, that algorithm throughout that network again, because there's been a topology change. And that is why if this was a hacker, someone with malicious intent, they might be sending those BPDUs deliberately into the network. And you don't want that. So if we actually defined that interface to be an edge port, and I'll show it in just a second, BPDU block on edge, then all those BPDUs that are coming into that interface from this evil malicious hacker here, they're going to be blocked, and that's not going to cause that spanning tree process, that algorithm to just run all over again and for the network to converge. And that can take some time, it can take at least 50 seconds. But you can also see the other commands that we can do. So we can also say no root priority, i.e. we do not want one of that interface, or GIGI003 in this case, to be a root port. Now with SW4 being the root bridge, that's not relevant, but this allows a network administrator technician to specify and tailor that switching network to prefer one port over the other. And then you've got the priority value just here as well. So the priority value is when you've got maybe multiple ports, each of them fighting to be a root port, and you need to define the priority of that port. Again, lower is better. So if switch 2 had multiple ports over to switch 1, which one would be the root port? Well, initially it depends on the lower priority value, but if there is a tie there, the next part they're going to come to is what is the best or lowest port priority, and then port ID. So that's what you actually define here. But we're not going to do any of that, so I'm just going to delete all of this and do show. So here are the commands that I've currently entered in. And coming back to that BPDU block on edge, if I just do set, note here at the top the set BPDU block on edge. So therefore, if I'd have set interface GIGI001, just for example, to be an edge port, and then do set BPDU block on edge, and let's just do a show again, you can see now that we are going to block any BPDUs that have been received on an edge port. And because GIGI001 is configured to be an edge port, any frames, any BPDUs that have been received from switch 1 on the switch 4 port on the GIGI001 interface will be blocked. They'll be discarded. So it's a good safety feature. I don't want it here, so I am going to delete that, because otherwise STP process is not going to work. But this is how you protect your network. One of the ways you protect your network from a layer 2 switching looping perspective in the STP world. But let's actually just delete that. So let's do delete interface GIGI001 edge, and let's also delete BPDU block on edge. Let's do a quick show, make sure it's all still there, and it absolutely is. Now, what is the last piece of the puzzle? What is the last command that I actually need to do? It is set the priority, or it's actually set bridge priority. So it's not set priority, set bridge priority. And you can see over here that the priority is 0. So we want absolutely switch 4 to be the root bridge. And if I do show again, that's it. This is quite literally the configuration. Yes, I went through a little bit more detail there, but we've got our GIGI001 with this particular cost. We've got our GIGI003 with this particular cost. We're forcing STP process instead of RSTP, even though RSTP is preferred. And the bridge priority of switch 4 is 0. So now if I just do a commit and quit, and let's let that spanning tree process, that algorithm kick in, and for all those other switches 1, 2, and 3 to decide and really agree on switch 4 being that root bridge. So here's the first command you could do. You should do show spanning tree bridge brief, and we can now already see that the agreed root ID across the network is the bridge identifier with the priority of 0 and this MAC address ending in 9FD0. What is the local bridge ID? You can see that down here. This is the local bridge ID, i.e. switch 4's priority and MAC address. 9FD0, 9FD0. That's it. Now if I actually come back over, just for example, to switch 2 and do the same command, show spanning tree bridge brief, what you should see is that it is also agreed on the 9FD0 being, i.e. switch 4 being the root bridge, but here is my local MAC address. And if I just do the same, just to prove it, show spanning tree bridge brief on SW3, you could see again it is SW4's MAC address. It's bridge identifier here. So all of them are agreeing that switch 4 is that root bridge. Coming back to, actually stay on switch 3, what we can also do is do show spanning tree. We can look at the interface, and if I hit question mark, you could see the brief of the interface. So let's do that first. So you could see all the ports. I'm not too sure where GigE006 is coming from. That's obviously not on there. I think it's a bit of a stale config. But do note over here, this value here, that is that long cost. That's why I wanted to do 4, because that's 20,000. That is the long cost versus the short cost. So yeah, that's why I've done the short cost. But more to the point, we can actually see, forget GigE006, we can actually see what ports are participating, forwarding, and which ones are the root ports. So we can actually see that the GigE004 port on switch 3, which is this interface here, is forwarding, and it is the root port. That is exactly what we wanted here. We wanted the root port, and we wanted it to be in a forwarding state. And then we've got the GigE002 interface, which points up to switch 2. This is forwarding, but it is designated. So we've got forwarding here and designated here. So that gives us information that really, yeah, the network has converged. And so let's move on to switch 2 now to see if that GigE003 interface, which is pointing down to switch 3, is blocking. So I'm just going to do show spanning tree. Guess what? Interface brief. And we can see the interface GigE003, which is going to switch 3 here. We've got the port priority here, just left it default 128. We've got the cost, but then we've got the state and the row. So it's alternate, basically means it's an alternate port. It's neither designated or root. It's just a backup as such. But it is absolutely blocking. So all the BPDUs, which are coming from switch 3 up to switch 2, yes, they'll be received. Yes, switch 2 are listening to them, but it's not doing anything with them. And thus, we're breaking the link in that network. But what are some other interesting show commands you can do? So if I just do show spanning tree, and let's just do statistics, hit question mark, and we can do that on the statistics on the bridge. So let's have a look at that. And we can actually now see the number of root bridge changes have been 5. It last changed at 13:52 today on this particular date, so it's just over an hour ago. The number of root port changes have been 7 with the last time as well. And when was the last topology change actually received? It was received on the GigE001 interface, which came from switch 1, and that happened again just over an hour ago. So it's when the network last converged. If I just hit up and do this now on the interface, we can now see all the statistics, the spanning tree interface statistics on these 2 ports. So we can see the number of BPDUs that got sent, that got received, how many topology changes have been transmitted and received. Have there been any proposals and agreements? These 2 here are the RSTP world, so that's 0 because we're using STP. But that is how you configure spanning tree protocol, and just a few commands to really understand the network, the spanning tree protocol, the STP network. What is the root bridge? What is your local bridge? What are those priorities that have been seen? When was the last topology change? And what are those rows and states on those interfaces? So very straightforward, very easy to configure. But what happens when you've got a host that suddenly has its interface disabled in the STP world? That would trigger a topology change. And here we go. Here is a user that I've just added into the network on GigE000 on switch 2. Now, in the real world, you would have this to block BPDUs. You would have this port to be configured as an edge port. So I know that this wouldn't be reality, but it's just to simulate what happens when this interface here goes down, when it's disabled. And what we will see is that there will be that TC, there will be that topology change, i.e. switch 2 is going to send over to switch 1 a topology change notification, and then switch 1 will send on that TCN onto the root bridge, which is switch 4, And then when switch 4, the root bridge, has received that, it will send onto the network that topology change itself. Now to see all of that, what we're going to do on this interface here is we're going to do a PCAP. We're going to do Wireshark and see these TCNs and the TCs coming in and going out respectively. And so here I am on switch 2. I've gone into configure mode, and it's just show you the protocol's RSTP on this particular switch. And here you can actually see I've got the interface GIGI000 pointing to user 1. Now what I'm going to do is I'm just first going to do set interface GIGI000 disable. I'm not going to commit to that just yet. I'm just going to have that there. What I will do is I'm going to enable and start that Wireshark on this interface here. So if I just go onto the switch itself, do capture on the GIGI001 interface, and there we go. I've got my PCAP running, specifically looking at the spanning tree protocol, those BPDUs in the background. And you can see there's a lot of just hello packets, typically every 2 seconds, just being sent out by the root bridge saying, hello, are you still there? And this is the configuration, this is the configuration. But let's commit this on switch 2. So I'm now going to be disabling that GIGI00 port. What we should see on the packet capture is that topology change notification. Now it might not be instant, because don't forget, with spanning tree we've got to wait for that max age timer to time out. And here we go, took way longer than what I was actually hoping it would do, so that was a bit of a waiting game for me. But you can actually see what has happened is under here, and let me maximize this, and what you can see is we have received from switch 1 that topology change notification that originated from switch 2. Now I'm not going to go into these first 3 headers. I'm really just interested in the TCN header. To be honest, there's not much in the TCN header, but look at all the timers that you get in the BPDU, the forward delay, the hello, the max age, and the message age. So this was just 0, so that basically means it's come straight from the originator, i.e. from switch 1. But we can also more importantly see that this is a configuration message. Have there been any flags actually set? And this is just indicating that there has been a topology change notification. On the next message down though is where we actually get the topology change. So this is from the root bridge switch 4 saying, yep, actually this is the acknowledgement of the topology change notification. So you can actually see TCA here, the flag has been acknowledged, it's been enabled for this topology change. If I go to the next one, we can now see that this is then the topology change. So first it received the topology change notification, it sent out the topology change acknowledgement, and then following that the root bridge made a topology change, and that would have been sent out of the GIGI001 port and out the GIGI003 port to switch 3. So quite interesting. I'm sure you will agree when you actually see all this theory coming to life and the BPDUs just in a packet capture. So quite interesting. And that's it, everybody. That is the end of this video. That's the end of this part in Spanning Tree Protocol, STP. As I said, it's very quick, very easy to configure STP, but you've always got to be aware of that convergence process and the BPDUs and the timers that come into it. But from a Junos perspective, it's so straightforward in configuring STP. You go into Edit Protocols, RSTP, you force the version to be STP, you enable or you configure the interfaces that you want to participate in that STP process. Maybe you want to do other things like the extended system ID to identify what is the VLAN for this spanning tree process. And then you've got your bridge priority as well. So the priority which comes into effect when initially all the switches are deciding who is the root bridge. Lower priority being the better, the more preferred priority. And then of course you've got your extra configurations like BPDU, block on edge, and configuring those interfaces to be an edge port and the cost associated to that. That is so straightforward, so easy, and likewise I hope you found this video easy and straightforward. If you like my content, please give me a thumbs up. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. I love hearing from you all. Other than that, thanks for watching and goodbye.